Hello friends, in this lecture I would like to explain another example based on the stiffness matrix method. See here, already I solved so many problems based on the stiffness matrix method, that is based on the continuous beam, and again in that sinking of the supports, and again stiffness matrix method based on the non-sway analysis. But here the problem based on the sway analysis based on the unsymmetrical loading and different heights of the columns. So therefore, there is small difference in the procedure for the non-sway analysis and at the same time sway analysis. First, I will write down the sway conditions for the frames. So see here, what are the sway conditions? So first one is unsymmetrical loading. Unsymmetrical loading, unequal heights of the columns. See here, column AB will be 4 meters and column CD will be 2 meters. That is the reason this comes under the sway analysis. At the same time, unsymmetrical loading. Here, 30 kilonewton per meter act on the member BC. And again, one extra force, which is horizontal force, exactly acting at the joint B. So, which leads to the unsymmetrical loading here. So, based on these two conditions, the frame here is the sway. The frame comes under the sway analysis. Okay. And again, equal, unequal, sorry, write down different moment of inertia of the columns. Different moment of inertia of the columns. And again, different end conditions. For example, what are the different end moment of inertia of the columns? For example, this column consists of some 2i and this column consists of some I or 3i. That time also this comes under the sway analysis, but here the property will be same only. And again, different end condition means at end A it is fixed, another end D it is hinged. At that time also it will comes under the sway analysis. But here different same end conditions and same movement of the inertia of the columns, but unsymmetrical loading and unequal heights of the columns. Therefore, the column comes under the frame comes under the sway analysis. So the procedure will be somewhat different. We have to add thinking, that is 6ci delta by L square for the sway problems. I will explain how it will be added to the frames. And at the same time, what is the first step? Each and every time while solving the problem based on the stiffness matrix method, you have to find the unknown displacements. For example, unknown displacements based on the degree of freedoms. Already I solved one non-sway analysis procedure. In the same way, you have to find the unknown displacements. So see here, at end A and end D, it is fixed. There will be no degree of freedom. But at joint B, you will get 1 degree of freedom. And joint C, you will get 1 degree of freedom. So therefore, 2 degree of freedom, one at joint B and another at joint C. And one unknown displacement based on this way. So totally there will be 3 unknown displacements. Unknown displacements are 3. So what are those? One is based on the sway, another one will be rotation at B, another will be rotation at C. Okay. For example, I will tell you one more thing here. So the frame consists of like this. See here, the frame both ends will be fixed and same height, that is 4 meters, 4 meters, and equal distribution of the loading, and at the same time equal moment of inertia for the columns for the both. See here this type of frames will comes under the non-sway analysis because same end condition, equal height of the columns, equal moment of inertia, and symmetrical loading. But what are the unknown displacements here? Here you will get only two unknown displacement, one at joint B, another one at joint C, means rotation at B and rotation at C. But here there will be one more unknown displacement comes extra here, that is sway here. So whenever spray comes, you will see first one will be sway, another one will be rotation at B, another one will be rotation at C. Here for non-sway analysis problems, you will get for the same frame, you will get two unknown displacement, one at joint B, another one at joint C. For example, if there will be one more extension like this, here it will be hinged. At that time you will get another displacement which is a jointed D or another area. So at that time you will get one more displacement due to hinged. But if it consists of two columns and one beam, at that time you will get only two unknown displacement. Here one more extra unknown displacement comes for the sway problems. That is, unknown displacements are due to sway, another one will be B, another one will be rotation at C. Okay. So after knowing the unknown displacement, so you will get 3 by 3 matrices to solve the problem. So you people know the formula. Already we solved 3 by 3 matrices previously while solving continuous beams under the frame also. Then here one more force will be given. Okay, that is 50 kilonewton, which is acting exactly at joint B. So we can take this is as external forces. For example, I will tell you here. First I will solve you the external forces. First, see here, what is the formula for the 3 by 3 matrices? We people know, that is, so your unknown displacements are delta 1, delta 2, delta 3. So that is one for sway and remaining two are delta 2 and delta 3. So I will take down the delta 1 will be same like delta, and delta 2 will be theta B due to rotation at B, and theta delta 3 will be theta C for my remembrance purpose. Okay, and that one will be equal to, so for 3 by 3 matrices you will get like this: K11, K12, K13, K21, K22, K23. So all these are the stiffness matrices. We have to find this one: K31, K32, K33, and again it will comes under the inverse. So already I shown how to simplify this formula, and again P1, P2, P3 minus P1L, P2L, P3L. So first take this only external forces part, that is P1, P1L. So how you will obtain all this P1, P2, P3? See here, 50 kilonewton will be acting exactly at joint B. So this force will comes under P1, that is 50 kilonewton, and remaining P2 and P3 will be 0 here. And what about this P1L, P2L, P3L? These are based on the given loading condition, which is based on the fixed moments. Okay, so this procedure will be same like as non-sway analysis, but at that time, so see in our channel playlist, so I solved one problem based on the non-sway analysis. There will be no external force given in that frame, therefore that P1, P2, P3 will be 0 in the last problem. But here one force will be horizontal force exactly acting at joint B, so therefore we are taking this condition, that is P1. For example, if the same force acting in this direction, you can take that is P3 also, no problem. But here it will be acting towards right at joint B, so therefore we are taking P1. So this also leads to the sway here. Whenever horizontal force exactly given to the column, this also leads to the sway. Therefore that P1 will be comes under 50, and remaining P2 and P3 will be 0. There will be no another forces given in the particular problem. And what are the fixed moments? See here, first to find out the fixed moments. So fixed moments, M bar AB, M bar AB equal to M bar BA will be equal to 0, because there will be no forces given in the column. Similarly, what about M bar BC? M bar BC will be equal to minus WL square by 12, because UDL will be acting. So if you simplify, what you will get, minus WL square by 12 means minus 30 into 4 square by 12. So how much it will be around? It will be minus 40 kilonewton meter. Similarly, M bar CB will be equal to plus 40 kilonewton meter, that is plus WL square by 12. Similarly, M bar CD and M bar DC will be equal to 0. So I already told you so many times. What about P1L? P1L will be 0 here, because we are taking that first unknown displacement, the delta 1 will be based on the sway forces. So here already one external force will be taken P1. And what about P2L and P3L? So that is rotation at B and rotation at C. Therefore sum of the moments at that particular joint, that is M bar BA plus M bar BC. Similarly, P3L will be M bar CD plus M bar CB plus M bar CD. This one will be equal to 0, this one will be equal to 0. So if you take P2L will be M bar BA plus M bar BC, means M bar BA will be equal to 0 here. M bar BC will be minus 40 kilonewton meter. So here P2L will be minus 40. Okay. And P3L will be M bar CB will be plus 40, M bar CD will be 0. Therefore, you will get plus 40 here. If you simplify this entire forces, you will get this P1, P2, P3 minus P1L, P2L, P3L. So if you take down these values, 50, 0, 0 minus of P1L, minus of 0, and again this P2L minus 40, and again this P3L plus 40. See here, again if you simplify this one, how much you will get? 50 plus 40 minus into minus plus, and again minus 40. So these are the total forces. So this entire parts will be for 50, 40 and minus 40. So this is the way we have to find the forces on that particular frame. For example, if this force 50 kilonewton is not given, at that time what you will get? So there will be three unknown displacement only. In the place of P1, P2, P3, both will be 0. For example, there will be one more question like this. I will show you the difference if force is not given, how you can consider these external forces. For example, I will take the frame only up to here. So there will be no horizontal forces given. So I will take down that value also here. So assume here there will be no forces will be given. So only BC and CD will be there. At that time also you will get 3 by 3 matrices, because this will comes under this way analysis. The problem comes under this way analysis. Therefore you will get 3 by 3 matrices to solve the problems. So your P1, P2, P3 minus P1L, P2L, P3L. But here there will be no external forces given in this type of problem. See here I am talking about this problem. So therefore this one will be 0, this one will be 0, this one will be 0, this one will be minus 40, this one will be plus 40. If you simplify you will get 0 plus 40 minus 40. Okay, this is the external forces given in this particular problem. But here one horizontal force is given exactly at joint B, therefore you will get one external force which is at joint B, joint due to sway B. Therefore your P1 will be 50 kilonewton and P3L, P2L, P3L will be based on the external forces given in this particular problem. See here, this is the small differences. When external forces is given in the particular problem, you have to consider like this. Otherwise, you can simplify like this: 0, 40 and minus 40. Then solve these one, K11, K12, K13. So next step is same like as the previous problems only. See here, what is our next step? After finding the external forces, our next step is to find the K11 matrices. So for that one, so I will write down, that is stiffness matrix. So we know first what is our first step. First we have to fix the entire structure. Our first step is we have to fix the entire structure. So I am taking the same problem like this. Then fixing the structure, fixing the entire structure. So this is the problem, which is called fully restrained structure, which is called fully restrained structure. And after that what happens? We have to apply delta. First is we have to apply unit displacement in coordinate direction 1, that is K11. Okay, here delta equal to 1, that is delta value. See here, after the restraining structure, first what is our first step? You have to apply this way, releasing the structure at B and apply unit rotation at B. Okay, that is K11. Okay, for that one what we are taking? So this is A, B, C, D. So generally whenever sway leads, it will be like this. So the position of the frame will be like this. So this is B dash C dash. Okay, so the original frame will be ABCD. Whenever we have to apply some sway force, so after the application of this sway, the original position of the beam will be leads to A, B dash, C dash, D. Okay, so that is delta equal to 1. See here, if it will be bends like this, I will take one external force which is acting like this, means the beam will be like this. If I apply any force, there is a chances of moving the beam from here to here. Therefore, I am taking anti-clockwise here, okay, which is B to B dash. In the same sense, if the frame leads like this way, I am applying anti-clockwise force based on the sway. So this is one unit which is 6CI delta by L square. Okay, so whatever the force acting here, the same force will be applied like here also, which is 6CI delta by L square. Similarly, if you see here, here also the frame leads to sway like this, okay, towards right. So here also I will apply anti-clockwise force here. Why means, already I told you the same logic. The frame will be like this. If apply any force, there is a chance of moving the frame in the front direction. So like this, here also I will apply 6CI delta by L square. So your delta will be equal to 1. So directly take down 6CI by L square also. Here the same rotation will be applied like this, 6CI delta by L square. So in the continuous beam, what we are taking, so this is the continuous beam. We know the continuous beam application. So this is A, B, C. So in the problem, if they will ask is delta B will be sinks by some 5 mm. So what is the diagram? So it will be sinks some 5, that is B to B dash. Your diagram will be like this. Okay. So this is 5 mm. So what are the movements takes place here? So we know whenever your left hand support is at higher end, you will get both will be clockwise movement. That is 6CI delta by L square. Similarly here also 6CI delta by L square. Whenever your right hand support is at higher end, you will get both moments will be positive. 6CI delta by L square. Here also 6CI delta by L square. But here there will be no such type of conditions we have to remember. For that only I am telling in logical way. Your beam will be like this, your column will be like this, A to B. So if it will bends like this, what I am telling means, if I applied an anti-clockwise force like this on the beam, so the beam B will tends to move up to somewhere, that is B dash. So therefore, if an anti-clockwise force is applied here means automatically it will move in the forward direction. Therefore, in that logic I am taking whatever the force applied here, the same force taking here also. See here whatever the force applied, the same force taken here also, both are anti-clockwise. Whatever the force applied here, the same force taken here also, that is clockwise. Summation of these two minus plus will be taken as equal to 0 in the beams. But in the frames also you can remember in the same way. Whatever the force applied here, the same force will be taken to its other end. Whatever the same force applied here, the same force will be taken to the other end. So for the remembrance purpose only I am telling all this logic. Okay, then move to the problem. See here, this is 6a delta by L square. This is also 6a delta by L square. This is also 6a delta by L square. This is also 6a delta by L square. Then next step is the frame will be like this. Again, you have to understand the problem completely. What I am telling here. This is somewhat difficult comparing to the sway analysis, non-sway analysis. So here, purely I am taking one element. So in the AM frame, I will take one element, that is completely AB element. Otherwise, you can take aside somewhere AB element. Somewhere take like this AB element. Completely I am taking AB element, and also apply what are the forces acting on that element. So see here, there will be one anti-clockwise force acting, that is 6EI delta by L square. Similarly, anti-clockwise force is acting, that is 6EI delta by L square. So what about delta? Delta will be equal to 1. You don't take delta also, it will be okay. 6EI by L square, 6EI by L square. So here we have to find the horizontal forces. Okay, so I will apply horizontal force like this. Okay, that is HA, or else I am taking here. So 6A delta by L square I will write down here. So I will apply horizontal force, that is HA will be equal to here. So for finding horizontal reaction while solving moment distribution method horizontal frame, for finding horizontal reaction at A, already I explained what is the formula for finding horizontal reaction at A. So I already explained in the previous problems while solving moment distribution method, Canis method, how to find the horizontal reaction at A based on the formula. That is, horizontal reaction at A will be equal to sum of the moments of the column by length of the column. What are the sum of the moments here? 6EI delta by L square means that 6EI by L square plus 6EI by L square, and again by length of the column. So here HA will be equal to 6 plus 6 12 EI by L square into 1 by L, which is L cube. See here, your HA will be equal to 12 EI by L cube. So these two are acting anti-clockwise and this is acting opposite to that one, which is clockwise. Therefore, negative will be cancelled. You will get HA will be equal to 12 EI by L cube directly. Otherwise, you can solve the problem by using sigma MB will be equal to 0. So I am resolving all the forces directly here. Clockwise moments one side, anti-clockwise moments another side. So resolve this one, HA into 4, which is clockwise direction. And what are the anti-clockwise moments? That is 6CI by 4 square, L in terms of 4 meters here. Again, this one also anti-clockwise moment, 6CI by 4 square. So you will get same, that one will be equal to 6EI by 4 cube. Sorry, 12 EI by 4 cube. This is also 12 EI by L in terms of 4 cube. So your horizontal reaction at A will be equal to 12 EI by 4 cube. Similarly, what about horizontal reaction at B? For example, sigma H will be equal to 0. So I will apply horizontal force like this. HA will be equal to HB. Therefore, this one also will be equal to 12 EI by L cube. So some of the horizontal force, one will be acting right towards right wing, another one will be acting towards left. Otherwise, you can apply here HA plus HB will be equal to 0. HA will be equal to minus HB. So automatically your direction will be changes because of that negative value. Therefore, your HA and HB will be equal to 12 EI by L cube. In the same way, you can solve this element, that is CD element also. So I will take this CD element aside. This is the CD element. Okay. So what you can resolve HD here? How much you will get? 6EI by 6EI delta by L square. L in terms of 2, that is 6EI by 2 square. Similarly here also 6EI by 2 square. Delta equal to 1, L equal to 2. See here, again for finding HD, that one will be equal to sum of the column moments by length of the column. Sum of the column moments will be 6EI delta by L square, 6EI delta by L square. That is 12 EI by 2 square. By length of the column will be 2 into 1 by 2. You will get that is 2 cube. Directly I am taking 12 EI by 2 square by L, that is 2. So I am talking like this, 12 EI by 2 square by 2. So sending this to upper side, you will get 12 EI by 2 cube. Okay, so this one will be 12 EI by 2 EI by 2 cube. In the same sense, what about HC? HC, one will be acting towards right, another will be acting towards left. Why? Because sum of the moments on the column will be equal to 0. HA, HC minus HD will be HC plus HD will be equal to 0. At the same time, you will get HC will be equal to 12 EI by 4 cube. Sorry, 2 cube. 2 cube. So I am talking like this. HA plus HD, sum of the horizontal forces will be equal to 0. HA will be equal to minus HD. So HA will be equal to 12 EI by 2 cube. HD will be equal to 12 EI by 2 cube. So here negative will be there. Therefore, one will be acting towards left, other will be acting towards right. Okay. So these are the forces which are acting on that particular sway forces. So finally, what you are observing means 6EI delta by L square based on the sway rotation and 12EI by 4 cube. So finally, I will take down all the elements here in this particular problem. In this particular diagram. See here, two forces which is acting, that is 6EI by L 4 square. Similarly, here also acting 6EI by 4 square. Here also it will be acting 6EI 2 square. Similarly, it will be acting 6EI by 2 square. Okay. So I am removing all these things. Already I simplified all these things here. Otherwise, you will be confused. Okay. So all these are the moments due to sway. And again, your HA will be equal to 12 EI by 4 cube. Your HB will be equal to, so it will be acting here, 12 EI by 4 cube. So we know the force sway will be like this. And again here also the force will be like this. Here also your HD will be equal to 12 EI by 2 cube. And your HC will be equal to, that will be acting here, 12 EI by 2 cube. Okay. These are the forces HA, HB, HC and HD. Then talking about K11. So I will take down K11 here. So that is K11. So K11 is based on the sway force. That is how much force will be acting here. That one will be equal to this 12 EI by 4 cube and this 12 EI by 2 cube. So after simplifying, directly take down this one. Directly take down this one. So what about K11? 12 EI by 4 cube, 12 EI by 2 cube. So that is HC plus HD. HB plus HC. That is 12 EI by 4 cube plus 12 EI by 2 cube. So that is your K11 forces. So if you simplify, how much you will get? It will be around 1.6875 EI. And again, you people know, next step is K21. Next force. Based on this way, K21. So directly take down what is the remaining value here at B, that is K21. That is 6 EI by 4 square. So here due to anti-clockwise direction, take down negative here. Just simple. If you simplify, you will get this one as minus 0.375 VI. So whatever the force K21 you are getting, the same force will be for the K12 in the 3 by 3 matrices. We know that one also. Next one is K31. K31. That one will be equal to K13. We know that one. Already we solved previous problems like this only. But here what about this K31? This K31 is the remaining value at this point. That is 6 EI by 2 square, and due to anti-clockwise taking negative. So if you simplify, you will get this one will be around minus 1.5 EI. So you are observing what I am taking. So after resolving the forces, that is HA, HB, HC, HD. So whatever the forces acting at HB due to sway, I am taking this two combination 12 EI by 4 cube plus 12 EI by 2 cube as K11 and the remaining value at B will be the moment left here at B, 6i by 4 square, that is K21, and remaining value at C will be 6ei by 2 square. So this is the procedure for finding sway problems. So next application delta K22 will be same like as non-sway procedure only, but whenever you are solving sway analysis procedure, you have to remember this step. This is very important. So first to find out HA, HB, HC, HD, and HB plus HC will be equal to K11, and remaining moments whatever acting at B and C, you will get the distribution moment, that is K21 and K31. Okay, we will continue the problem. Finally, we will get what is the difference between non-sway procedure and sway procedure. So next is, we know, like as same for the non-sway analysis. So that is unit displacement in coordinate direction, that is K22. K22. I am talking about this one. See here how the diagram will be. So we know here also entire things will be fully restrained structure. So already we release the structure at B and apply unit rotation at B, that is K22. Okay, if you apply the moment, you will get sagging like this. Similarly, the same moment applied here, you will get sagging like this. Okay, if this will be K22, you will get next force will be K32 here, half of the moment distributed here, and again. So we know here we are releasing structure at B and applying moment at B. So this is the restraint structure. We know all the diagram will be same like as the previous problems. And K12 also you will get here only. So this is theta B. This is theta B. Here you will get theta C. Okay. See here, what about this K22? K22 will be equal to combination 4EI by, this is B, this is C, this is A, this is D. 4EI by LBC, this one LBC plus 4EI by LBA. So this part. So sum of the moments at that particular joint, the unit force, that is 4EI by LBC plus 4EI by LBA. Okay, that is your K22. Next, what about K33? Simplify this one. 4EI by LBC will be 4 meters. 4EI by 4 plus 4EI by 4EI by LBA also 4 meters only. That is 4EI by 4. If you simplify, you will get 4 cancel, that is 2EI. Then K32 will be equal to half of the moment which is carrying in 4BC part. So 4BC part will be this one, just half of the moment, 4EI by LBC. Don't take this LBA. LBA part will be different. So whatever the moment obtained in KBC, the same moment exactly half will be distributed to the other end, that is K32. Okay, that is 2EI by L is 4, that is 1 by 2 EI. Okay, 1 by 2 EI. K32 will be equal to half, 1 by 2 EI. Similarly, K32 will be equal to K23. So don't simplify again K23. So it is just K33 will be equal to K23. Like that you have to take. And again, you will get K12 here also. So what about K12? So K12 will be obtained here itself based on this way. So that is difficult to find here. Therefore, whatever the value obtained here in the K21, the same value obtained for K12. If you take down this one also, you will get directly like this only. But while solving sway problems, it is difficult to find K12 because each and every time whatever the moment applied here, it will be distributed exactly half to the other end. Okay, therefore your K12 will be equal to K21. Like that you have to remember directly here. And again, next is K33, unit displacement at unit displacement in coordinate direction 3. So I will take here diagram. So delta will be, that is K33. Unit displacement in coordinate direction 3. See here, this is fixed. We are applying unit displacement here, that is K33. So if you apply the moment, you will get sway like this in this frame, and again the same moment apply like this. You will get one more sag like this. Okay, so this is the variation. This is theta c, and here this will be theta b. So this is A, B, C, D. Okay, K33 will be equal to 4A by LCB, 4A by LCB plus 4A by LCD, 4A by LCD. We know what about LCB? Length will be, this one will be 4 meters, this one will be 2 meters. 4EI by 4 plus 4EI by 2. If you simplify, how much you will get K33? Your K33 will be 4, 8. So you will get simplify directly by using your calculators. 2 times 1 times. So this will goes 2 times, this will goes 1 times. You will get 3EI. So your K33 will be equal to 3EI. So here you will get K23. So whatever the moment exactly obtained here, half of the moment will be distributed here, that is K23. So K23 will be equal to half of the length CB, 4EI by length CB. Don't take down this CD part. Why? Because this is another element. Whatever the moment obtained in the CB part, you can apply the same moment exactly half to the other end. So that is 2EI by 4. You will get exactly 1 by 2A. So already while solving 3 2, I tell that part also. Here, if you observe clearly, K23 will be equal to half EI, K32 will be equal to half EI. The same moment obtained here, half EI only. So see here, and again what about K13? So here you will get K13 also. That one will be equal to what we simplified in the first step, that is this one, K31 will be equal to K13. Due to sway itself, we can simplify directly, that is minus 1.5 EI. You can take down that value directly, that is K31 will be equal to K13. So this is somewhat critical only. You can understand, first simplify the sway, based on that only, just you can go for next K2 to K33, and whatever the possible to distribute to the other end, you can distribute there itself. But don't be confused, this is somewhat critical only. Okay, so we got all the values, that is K11, K12, K21, K31, all the values. Just substitute in the formula, then see what are the moments obtained here. So this is the formula. So each and every values obtained here, I am taking below itself, here itself. So this is the formula. Okay, see here, find delta, theta b, theta c. So we know what about this K11. So K11 will be equal to 1.6875. Simplify just and take down directly. K22 will be, K12 will be 0.375. K13 will be minus 1.5. K21 will be minus 0.375. So it is better to write down straight to the theta b, that is minus 0.375, and again this one will be 2, and again this one will be 0.5, which is K23, and again theta c, that is straight I am writing here minus 1.5, that is K31, K32 will be 0.5, and K33 will be 3. And what are the external forces after simplifying? So that one will be, it is in terms of inverse. Okay, this is 50 minus 2 minus plus 40 and minus 40. If you simplify, you will get directly all the values in your calculator. that is delta theta b theta c. Okay, so that one will be equal to, if you simplify directly, you will get 35.556, 26.667, 0, 1 by EI. So all these are the values obtained based on the stiffness matrices. That is delta will be equal to 35.556, theta b will be equal to 26.667, theta c will be equal to 0. So after obtaining these values, next step is to find out the moments based on the slope deflection equation. So that is also very simple. I will explain. So finding the final moments. Final moments. So first one will be MAB. So what is the formula? M bar AB plus 2EI by LAB into 2 theta A plus theta B minus 3 delta by L. Okay. So you have to observe small difference here. So I will take the same diagram for my explanation purpose. See here. So what are the values here? Your M bar AB will be equal to 0. Here your M bar AB will be equal to 0 plus 2EI by length AB will be equal to 4 into theta A will be equal to 0 because of fixed, theta D will be equal to 0 because of fixed. So theta A part will be 0 plus what about theta B? Here we want theta B. So theta B will be 26.667. So take down that value 667 minus 3. What about delta value? So delta value is simplified 35.556. Okay, 35.556 by length. So length of that particular column will be around 4 meters equal to 0. Okay, if you simplify, you will get how much? This one will be around M bar AB will be equal to 0. If you simplify directly, you will get 0. Check once in your calculators. So this is EI 35.556 by EI. This EI and here EI will be cancelled finally. Then MBA. Next moment will be MBA. What is the formula? M bar BA plus 2EI by LBA into 2 theta plus theta A minus 3 delta by L. And again M bar BA will be equal to 0 plus 2EI by length of the column BA will be equal to 4 meters into 2. What about theta B? That is 26.667 plus theta A will be 0 minus 3 into delta will be 35.556 by 4. If you simplify again, you will get this one will be around 13.33 kilonewton meter. Then go to the next moment, that is MBC. MBC will be equal to M bar BC plus 2EI by length of BC into 2 theta B plus theta C. Don't take delta here. So that is the reason I am explaining each and every part here. So delta will be taken only for the columns, not for the part BA, BC, member BC, because BC is the element which is consists of only member, that is BC, beam, and AB and CD are the columns. Sway only leads to that particular column. So if you see here, while solving slope deflection equations, we are also applying the same delta value only for the columns, not for the beam portion. In the same way here also, delta whenever sinking will be given, you can apply that sinking value only to the column, that is AB, BA, CD and DC, not for BC. So you can remember this is your note point. And simplify here, M bar BC will be equal to how much? It will be minus 40 kilonewton meter, which is based on the UDL, plus 2EI by length will be 4 meters only into 2. How much theta B here? Theta B will be 26.667 and theta C will be, what about theta C? Here already theta C will be directly 0 only. After simplifying, you will get MBC will be equal to minus 13.33 kilonewton meter. Okay, sum of the moments MBA plus MBC, sum of the moments at the joint, that is sigma MB will be equal to 0, MBA plus MBC will be equal to 0. In the same sense, you can apply three more, you can find three more fixed moments, that is MCB. So MCB also M bar CB plus 2EI by L into 2 theta B plus theta C. Don't take delta. So substitute the value, that is 40 plus 2EI by 4 into 2 into 26.667 plus theta C will be 0. So take down how much the value, it will be around 53.33 kilonewton meter. Similarly, M bar CD, sorry, MCD column will be M bar CD plus 2EI by length of CD into 2 theta C plus theta D minus 3 delta by L. We know that theta D will be equal to 0 because of the fixed end. M bar CD also will be equal to 0 because there will be no force acting here. And again plus 2EI by length of CD will be 2 only. 2 theta C will be 0, theta D also 0 here, minus 3 delta value will be 35.56 by L. L will be 2 meters, that is EI, 35.56 by EI. So simplify, you will get MCD value will be 53.33 kilonewton meter. So see here, some of the moments at this particular joint will be taken also equal to sigma MC will be equal to 0. Then MDC will be equal to, simplify the same, M bar DC plus 2EI by LDC into 2 theta D plus theta C minus 3 delta by L. Substitute all the values. You know MDC will be equal to 0 plus 2EI by length of the DC will be 2 into theta D will be 0 plus this one also 0 minus 3 into 35.56 by 2EI. So the same value will get in terms of negative. This is minus 53. So this is minus 53. This is also minus 53.33 kilonewton meter. Check all the values once again. This is the way we have to solve the stiffness matrix method. So we have to analyze this frame by using stiffness matrix method when comes under the sway analysis.
Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.